Welcome to the tutorial on the unit circle part 2. In our last tutorial we learned about the unit circle and about what the values of sine, cos and tan represent in the unit circle. We learned that when an angle starts moving around the unit circle, the vertical distance created by this angle at the centre of the circle is equal to sine of the angle, and this horizontal distance here created by the angle at the centre of the circle is equal to cosine of this angle. The distance along the tangent, when the tangent is drawn to the circle at 0 degrees, this distance along the tangent is equal to tan of the angle at the centre of the circle. When we go around the unit circle, we can see what happens to these three distances as the angle changes. Let's look at the first quadrant to begin with. As the angle moves through the first quadrant and becomes larger, we can see how the vertical distance created by the angle increases and the horizontal distance created by the angle becomes smaller. We can also see that the distance along the tangent increases and starts to increase rather rapidly. When we get to 90 degrees, we can see that there's no horizontal distance at all, while the vertical distance created by this angle is positive 1 unit. We can see it's positive 1 because this point here is 0, 1, and we're on the positive side of the y-axis. If I now move through to 180 degrees, we can see now that there is no vertical distance, but the horizontal distance is equal to 1 unit, and it will be negative 1 because we are on the negative side of the x-axis. Move down to 270 degrees, and we can now see that the vertical distance is 1 unit, negative 1 now, because we're on the negative side of the y-axis, but the horizontal distance is 0. When we come back to our starting point, which is now 360 degrees, we find that this horizontal distance is positive 1 again, but the vertical distance is 0. Have a look at tangent as we move. We can see here that tangent is increasing on the tangent itself. When the angle gets close to 90 degrees, we can see it increasing really rapidly. What happens to tangent at 90 degrees? If I extend this angle out through the unit circle, will it ever touch the tangent? Obviously not. At 90 degrees, the angle is parallel to the tangent, and no matter how far we extend the angle out, it's never going to meet the tangent. Hence, tan of 90 degrees is undefined. If we try and find tan of 90 degrees on our calculator, we'll get an error message. This is the reason why. Tan of 90 degrees cannot be calculated and therefore is seen as undefined. Let's continue to move around the unit circle and look at what's happening in the second quadrant. We can see that this distance along the tangent is now negative because we are on the negative side of the vertical axis. As we move around the unit circle, we can see how that negative distance on the tangent is decreasing, and it continues to decrease until the angle reaches 180 degrees, where now there is no distance along the tangent at all. Hence, tan of 180 degrees is equal to 0. Continue around the unit circle to 270 degrees, and we can see that at 270 degrees, once again, the angle is parallel to the tangent. It really will not matter how far I extend this angle out beyond the unit circle. It will never touch the tangent, and hence tan of 270 degrees is undefined. Continue into the fourth quadrant and continue around the unit circle, and we can see again that the distance along the tangent is negative, but as we move closer to 360 degrees, that distance is decreasing. At 360 degrees, once again, there's no distance along the tangent, and tan of 360 degrees is 0. The other thing to look at as we move around the unit circle is whether the vertical and horizontal distance formed by the angle is positive or negative. Let's look at an angle in the first quadrant. We can see that this vertical distance is on the positive side of the y-axis, and therefore sine in this quadrant will be positive. We find the same thing with the horizontal distance. It's on the positive side of the x-axis, so cosine of the angle will also be positive. When we look at tan of the angle, we can see that this distance along the tangent is on the positive side of the vertical axis, so therefore tan of the angle will also be positive. In summary, we can see that all three ratios in the unit circle, if the angle is in the first quadrant, all three ratios will be positive. Let's now look at an angle in the second quadrant. For example, this one. We can see once again the vertical distance is on the positive side of the y-axis, and therefore sine is positive. However, this horizontal distance is on the negative side of the x-axis, so cosine of the angle will be negative. We extend the angle back through the unit circle, back towards the tangent, and we find now that this distance along the tangent here is on the negative side of the vertical axis, so therefore tan of the angle is negative. Let's look at another angle, this time moving around the unit circle and moving into the third quadrant. If we look at this angle, we can see that the vertical distance now is on the negative side of the y-axis, so sine in this quadrant is negative. If we look at the horizontal distance, it's still on the negative side of the x-axis, so cosine is negative. We extend the angle back through the unit circle towards the tangent, and we find that the distance along the tangent is once again on the positive side of the vertical axis, so tan in this angle is positive. Heading around the unit circle again, this time to the fourth quadrant, and we find that the vertical distance is on the negative side of the y-axis, the horizontal distance is on the positive side of the y-axis, and the distance along the tangent is on the negative side of the vertical axis. So in the fourth quadrant, we have cosine positive, sine negative, and tan negative. These patterns in the unit circle lead to us summarising each quadrant and summarising the signs of all of the ratios in each quadrant. So, we can see that in the first quadrant, all ratios are positive. In the second quadrant, we can see that only sine is positive. Tan and cosine are negative. If we continue around in the third quadrant, we can see now that only tan is positive here. Both cosine and sine are negative. If we continue around the unit circle to the fourth quadrant, this time we can see that the only ratio which is positive is cosine, sine is negative, and tan is negative. So in summary, only cosine is positive here. This pattern is summarised with the letters A for all, S for sine, T for tan, and C for cosine. We use an acronym to help us to remember this. All stations to central. A, S, T, C. This summarises the signs of all the ratios in the 4 quadrants.